Okay. So if you talk about the first topic that is interested to me is integrated nutrient management, or rather we can say IPNS, that integrated plant nutrient supply. Now, IPNS is defined as the maintenance or adjustment of soil fertility and of plant nutrient supply to an optimum level for sustaining the desired crop productivity through optimization of benefit from all possible resources of plant nutrients in an integrated manner. Now again, I will request all the participants to means interact. If they have any question at any particular point of time, they can just ask, and let this be an interactive kind of session, not a one way kind of teaching. Okay.
Yes, sir. Yes, sir. We have.
So that is what we know as IPNS. Now, integrated nutrient management is actually the technical and managerial component for achieving the objective of IPNS under farm conditions. Now, it takes into account all the factors of soil and crop management, including management of all other inputs such as water, agrochemicals, amendments, etc. Also, beside nutrients. Now, if we talk about different, means there are different components of INM. The most important one till today is fertilizers. Then there is organic manures. There is legume crops, crop residues, industrial byproducts, biofertilizers. So these are all the different nutrient sources that has to be considered when we are going to manage the nutrient requirement of a crop in an integrated manner. Now let's talk about fertilizers. So the farming that we do in our country post the green revolution era, that relies largely on fertilizers. Now obviously that's good because the fertilizers are a concentrated source of nutrient, and nowadays we are feeding a huge number of population with lots of high uh, yielding varieties. So if fertilizer and these high yielding varieties generally has a high nutrient demand, so without the fertilizers obviously their nutrient demand cannot be met and productivity will hamper, so we can't feed the population. So fertilizers are obviously the most important part of nutrient management in the Indian farming scenario. But over time, what actually happens, fertilizer consumption actually increased, and the fertilizer consumption trend in Indian scenario is more skewed towards the nitrogen fertilizer, because obviously the effect of nitrogen actually uh, on plant growth is very clearly visible just after application. So farmers tend to apply those nitrogen and they clearly omit the phosphorus, potassium, so obviously they omit, and they also generally do not go for micronutrient fertilizer application. So as a result, what we see, there is a development of multi-nutrient deficiency in several intensively cultivated fields. So that we don't want. So that's why the soil test based fertilizer application should be there, and also in an integrated manner. So uh, and since this high use of different fertilizers in our country, our farms, so the domestic fertilizer production is inadequate to meet that requirement. So and we generally import all of our potassium fertilizers from abroad, our phosphorus fertilizers, and also a huge amount of urea is also to be imported. And since there is a global price hike of the fertilizers, and also a price hike of raw materials, so the fertilizer import also is nowadays uh, is adversely impacted. So that's why we means there is a nutrient gap in our farms. Means what we uh, deliver, I mean, what we need to give and what we are giving actually. So how to bridge that gap? So to bridge that gap, we need to go to other indigenous sources and apply those according to our fertilizers and maybe some improved fertilizer materials that we have to apply. And in any case, the fertilizers that we apply nowadays, so the nutrients use efficiency is not that much higher. It is 30 to 50% in case of nitrogen, and maybe 15 to 20% in case of phosphorus. But for micronutrients, the nutrient use efficiency is very less, even less than 5%. So this how to increase that nutrient use efficiency, that needs a lot of research, and it should be a prioritized area of research for restoration and further improvement of soil health. uh, Means if nutrient use efficiency we may increase, then what will happen? It will improve the soil health, reduce the soil pollution, water pollution, and productivity also will be higher. And moreover, the farmer, the for the farmer's point of view, uh, his economic will increase. Means he will get more profit out of this fertilizers if you can decrease his fertilizer load by way of increasing the nutrient use efficiency. Now normal nitrogen fertilizers we have, mostly we use urea. Then uh, these are listed here. Mostly the farmers use urea. Then the farmers in this northern part, they also use the diammonium phosphate as a phosphorus source, which also supplies nitrogen. Then single superphosphates for potassium, potassium chlorides or potassium sulfates are the most popular fertilizers that we use. Now, these are very common fertilizers that we know, and we can have a lot of information in different books. So let us talk about something more advanced in this fertilizer sector in Indian condition, obviously. So one of that improvement in this fertilizer sector of India is customized fertilizers. Now, this custom means it's based on a soil testing approach. Means first we have to test some soils from an area, maybe prepare a map, and then we need to know what is the fertilizer or nutrient demands of this area for obviously a particular type of crop that is grown in that particular area. So based on those nutrient requirements, we can customize some fertilizers, customize mixtures of some fertilizers we can develop for some particular area. Uh, Now there are several practices, ways of doing this preparation of customized fertilizers. Number one is bulk blending. It is basically pure mixing of solid fertilizers to obtain a desired nutrient ratio beneficial for a particular crop, for a particular agroecological region, for a particular climate, and for a particular period of time in the year. So there, it's a basically a physical mixture, and obviously it is not of means that high response because it creates an irregular distribution of those different fertilizer material near the root zone. Now, an improvement from that bulk blending is the compound granulation. It is also known as the steam granulation or physical granulation. Here, the raw materials obviously will be the same as the bulk blending, the conventional fertilizers like urea, DAP, sulfur, pustules, or zinc, boron, or copper powder. So then they are blended through water, steam, and heat in a dry. It's a fusion blending. So those then it will form the customized fertilizer granules actually, and they can be actually uniformly distributed in the root zone, and we can expect a better kind of response from those customized fertilizers in terms of nutrient use efficiency, in terms of nutrient uptake, and also in terms of soil health and crop productivity. So that is a compound granulation, where also we are using a particular kind of fertilizers, normal fertilizers. We mix them, but through a steam granulation process. Then there is another process which is totally different from this two. This is known as chemical granulation, also is known as slurry granulation or complex granulation. Here, this NPKs are means this fertilizer are generally known as NPK fertilizer, means certain grades 26, 26, 26, or 18, 15, or something like that. So in this process, these fertilizers are produced by chemical reactions, not some physical fusion that was done in case of the compound granulation. Here, chemical reactions are being done between ammonia and either sulfuric or nitric acid to form either ammonium sulfate or ammonium nitrate. Now, those are then granulated with the addition of discrete potassium oxide K2O, either in solid form or in a liquid form. Then the process of granule formation comprises this accretion plus agglomeration, and that's how this kind of customized fertilizer we can produce. So here basically a new type of compounds is prepared due to chemical reaction between mostly ammonia and with nitrate or maybe sulfate. So that is customized fertilizers. Then another new fertilizer that is getting very popular in market nowadays, those are nano fertilizers. Now, every other fertilizer company is finding way or developing some nanomaterial. Several ICR institutes are also in active research for development of this nano fertilizers and how they can actually improve the nutrient use efficiency scenario of Indian condition. Now, what is this nano fertilizers? Now, this nano fertilizers. Now, first we need to know what is nanomaterials. Now, this nanomaterials are nano means 1 billionth. So, the size of a nanomaterial is typically in nanometer, that is 1 to 100 nanometers. That is a billionth of a meter. So those are nanomaterials. Now, this nanomaterials, it is having obviously low size, then obviously it is having a high surface area, and it is having a very different surface chemistry as compared to the normal particles of same composition. Okay. Just 1 second. Okay, so sorry for the interruption. So इधर इधर क्या करोगे? नहीं, इससे मत डालो. Just 1 minute. Okay, sorry for the interruption actually. Let me just continue. So we are talking about the nano fertilizers, and so by decreasing the size of a material to the nano range, we can actually change its surface properties, surface chemistry, and that is used in a multiple uh, mode to increase the nutrient use efficiency. Now, in general, the nano fertilizers can be of three types. First one is nanoscale fertilizers, which is nanoparticles, means nanoparticles which contain nutrients. So itself, their size is very less. Then there is nanoscale additives, where the traditional fertilizers with nanoscale additives are being used. Then the third type is nanoscale coating. Means traditional fertilizers will be used, but it is coated with nanoparticles, maybe some natural nanoparticles, which is mostly important. दिखाना 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 वही है ना, बोरोसिल वाला जो है, ठीक है, बट ठीक है, बट इसको ऐसे ही रखना, आप ध्यान से रखना, अंदर कुछ ना जाए, खराब हो जाएगा. Okay, so uh, these are nano fertilizers. Now, nano fertilizers, if it is used with some coating, means some nanoscale coatings. These nanoscale coatings can be prepared from natural clays actually. Means nano means natural nano clays, nano clay polymer composites we can prepare. Means our division of soil science in IRI is working in this aspect for such a large time, and we came out with some very good breakthroughs. So those nano clay coatings on a fertilizer material, they can actually that can be used as a slow release fertilizer material, where the fertilizers means the nutrient are released from those slow release fertilizers in synchrony with the crop demand. So that is a way of improving the nutrient use efficiency, obviously. Then some of the nanoparticles, means nanoparticles fertilizers, the first one type. Nowadays, nano urea is in the market, so it is also a nanoscale particle of nitrogenous compound. So that can be directly sprayed, means directly sprayed to the plant leaf, and some leaf absorption may take place, and due to its increased uptake, means the plant root parameters are also we found. Means we are also having a trial, several research trials on this nano urea, and we can see there is some benefits on the root scenario of different plants. So in a way, that is also increasing the nutrient use efficiency of that applied fertilizers. And means if means some result, if we talk about results, the application of this phosphorus nano fertilizer, we can reduce the recommended P doses to half of it, because due to this slow release, there is a significant reduction of phosphorus fixation in the soil. Then again, we did not till date we have some recommendations of nano urea, but the research results up to date, they show, means we can save like 25% of basal urea application with 2 nano urea sprays. So they can also be incorporated, this kind of fertilizers, in the fertilizer schedule for improvement of nutrient use efficiency. Then another very important use of different fertilizer materials of advance, that is the use of water soluble fertilizer through a fertigation system. Now fertigation system means fertigation through drip systems, that's or maybe sprinkler, but the more beneficial or the most beneficial is the uh, drip systems. Now here basically the water requirement of the crop is also very minimized. So drop wise water generally goes to the root zone of that plant, and that is very that is very economic use of soil water. And through that irrigation system we can also use some water soluble fertilizers like monoammonium phosphate, monopotassium phosphate, or other NPK mixtures which are completely water soluble along with urea obviously. So if those we can mix with that fertilizer water and go feed the plant roots directly, so then I guess we can save a lot of fertilizer material. And since we are directly giving those fertilizers to the very specific point of plant root, then there will be a saving of plant nutrients, and also nutrient use efficiency will also be much higher. Now there is two type of drip system. One is surface drip, another one is subsurface drip. Now if you are going for a surface drip, so there the water comes from the above the surface. So in that context, the subsurface drip irrigation system is much more beneficial as compared to the surface drip, because in there directly in the root zone we are giving the fertigation, the fertilizer nutrients. So obviously the amount of leaching, amount of volatilization, means volatilization, denitrification, this kind of losses will not occur, because we are not exposing the fertilizer even to the surface. That is going directly to the plant root. And maybe if we can synchronize with the different plant growth stages, the fertilizer application rate, so there will be maximum utilization of that different fertilizers, and we can have very high nutrient use efficiency for phosphorus also. If you are supplying the phosphorus in the root zone only, then we can expect that very less amount of phosphorus precipitation will be there. So phosphorus fixation will be very less, and obviously the use efficiency of the nutrients will be very high. Then let us, those are the fertilizer materials. Then we can talk about some of the industrial byproducts that we can actually, that is, now if we talk about industrial byproducts, so industrial byproducts has a use, means it's a, basically it's a hazard to the environment. Industrial byproduct, those uh, means means getting rid of those industrial byproducts is a headache for the society. So if they can be used in the agriculture, so that is a win-win situation. We can utilize those things, and since this may be having a high amount of organic matter in them, so it will be beneficial for soil health, and it can also uh, substitute some of the nutrient requirement of the crop. Now, in this industrial byproducts, one very important one is press mud. This is the compressed sugar industry waste produced from filtration of the cane juice from the sugar mills. It is a good source of fertilizers, and the total supply of sugar press mud varies from 1 to 7 kg from a processing of 100 kg of sugar cane. Now, this is a very good fertilizer agent since it's rich in micro and macronutrients along with organic carbon. So it's a eco-friendly approach, and it can be used in the areas which is located nearby those sugar mills. So this can be used. Then another industrial byproduct is fly ash. It is the end residue from combustion of the furnace of thermal power plants, and it also consists of several mineral constituents of coal, which is not fully burnt, and it has potentiality in agriculture use as a mineral fertilizers, because this is having very high concentration of different elements like potassium, sodium, zinc, calcium, magnesium, iron, and And several studies actually report that it increases the plant productivity, and also it is also helpful in reclamation of some soil acidity and also soil alkalinity based on the pH of that particular fly ash which we are using. Then in the steel making process, in the steel industry, basic slag is produced. It's an alkaline slag resulting, and it's a phosphorus rich material, and it is insoluble in water and does not cake, and it is having more than 14% P2O5 in citrate soluble form. So in acid soil, this basic slag can be used as a phosphorus source. Then the mining industries, which actually deal in the basalt rock mining, they also generate a huge amount of basalt rock dust. So those rock dust also is a very huge source of silicon mainly, then some phosphorus, some potassium, maybe some copper, boron, sulfur, they generally have. So those can also be used in this different nutrient management schedules as a fertilizer material, and this also improves the soil carbon scenario, improves the soil carbon sequestration potential. So they can be used also in the nutrient management protocols. Now another important, the most important rather we can say, apart from the fertilizers, are the organic manures. Now, organic manures is obviously the materials which is organic in nature. Most important, most common, I must say, that is the cow dung manure, the farmyard manure that we know. Then crop residues, human excreta, city refuse, compost, sewage, sludge, and many other. Some oil cakes, maybe some means uh, other industrial byproducts like spent waste from distillery, molasses. So those can be used. So this actually, apart from supplying of different nutrients, since it's organic nature, it supplies a very high amount of carbons or soil organic matter input to soil. So by way of doing that, it improves the physical, means it obviously improves the chemical properties of the soil, and also it increases the soil biodiversity, soil microbial count, microbial biodiversity, and also the enzymatic actions of those microbes in soil. And by way of doing that, it actually improves the soil aggregation. And while improving the soil aggregation, we have a very stable soil, a soil with a stable physical properties, stable physical nature, and in those aggregates we can have more organic carbon sequestration. And since it is having a stable structure, the water percolation, water infiltration, hydraulic conductivity, those kind of properties will also be very good. They are benefited from use of this organic manures. And the use of these organic manures, we have several long-term experiments, maybe under IFS or maybe also under the long-term fertilizer trials. So there, these results have been substantially proved over time and again that the 25% of the nitrogen requirement can actually be given through this different farmyard manures, and it is obviously better than sole fertilizer application. And this integrated nutrient management actually it yields, it give yields maybe slightly higher than this sole 100% NPK. And oftentimes it has been found that these yields are actually similar, statistically similar to the 150% NPK plots, and but the improvement in the soil fertility, if we see that in from that context, the NPK plus FIM plots, those are having a very they are rich in organic carbon. They are having a higher amount of available NPK, and the biological parameters are also very means they are having a very good biological health as compared to the soil fertilizer treated plots. And from a carbon sequestration point of view, they are also having a higher potential of carbon sequestration. More aggregation were found in those soils, and also the carbon those are sequestered in those samples, those plots, they are also having a lesser amount of temperature sensitivity, means they are less prone to loss to the atmosphere in due course of time. So that's why this farmyard manure or cow dung manure, those need to be an integral part of this integrated nutrient management package. So there is this list of different organic manures and different recyclable waste and their nitrogen, phosphorus, potassium content. So we can see there are animal meals, oil cakes, animal waste, and different farmyard manures or compost. Now, the only problem with these manures are they are actually having a very less amount of nutrient content. So that's why they are composted to decrease that increase that C's to N ratio, and to concentrate those materials, concentrate those nutrient contents in those materials. So that's why that's why composts are more preferred kind of these manures as compared to farmyard manures. But to increase the availability of compost towards this nutrient management at a country level maybe, so we need to promote the community composting practice in each village level, maybe city level. So means each grassroots level we need to address in a what you can say in a from a policymakers viewpoint, we need to promote the community composting. So their facility means composting means collecting points should be made for compost materials, means the organic inputs, the waste materials. Collecting points needs to be created, and contributors to also some monetary benefits to be made available for them. Composting units need to be developed in those waste collection centers. Mechanized composting should be developed. So by way of doing this, what we are doing, we are actually decreasing the load of this waste materials from the environment. Otherwise, these are basically a pollution element, and we are converting that waste material to a wonder, basically, which is compost, which can supply nutrient to our crops in different. So this recycling, this is basically nothing but recycling, and if we see very closely, then uh, this recycling is the key word if we want to save our planet and also go for higher production, also go for it's a sustainable future of the mankind, if we can say. So so that's why this community composting is a very good concept that need to be followed in our country. And in this community composting, the municipal solid waste that takes a larger portion. Means if you visit any city, not only the metros or large city, any small cities also, means if you visit Delhi or maybe Mumbai, maybe Bangalore, you can see in the outskirts of those big metros there is some dumping grounds. For Delhi, there is 3 dumping grounds outskirts of Delhi, and those are very environmental, what you can say, those are basically hazard to the environment. Means all the municipal solid waste they're dumping in those dumping grounds, uh, so those are basically getting lost there. Means there is some fruit peels, some like your vegetable peels, some material from some other food materials, maybe some uh, tissues, maybe some this paper, means all those cellulose kind of materials, some animal waste also, and the most important and the hazardous thing there is plastic. So all the other materials, means those are degradable, they can actually degrade in there, and they are of no use in those dumping grounds. But those plastics, they are present there, and they actually pollute our system, pollute the soils obviously, and also some microplastic from those dumping grounds can actually find their way into the streams, the water materials, and we are basically taking those microplastic through maybe some fish consumption, maybe. So that needs to be stopped for a sustainable future from for our planet, for our mankind. So that's why this community composting or preparation of city compost from this municipal solid waste needs to be prepared, or needs to be done in every major city of our country. Not only city, every major city, town, uh, village, everywhere. So that is the main way, and in this way we are actually developing a compost material which is very nutrient rich, and we can apply it in our nutrient integrated nutrient management protocols. So now this municipal solid waste means compost formation from this is generally happen with this composting process. First step of this composting is segregation of the different materials, means whether it's an organic material or it's a plastic, or maybe all that organic material according to their size range. We need to first segregate those materials, then windrow formation, and we have to use some culture, some microbial cultures which can actually degrade those materials in a faster rate. Now this decomposition uh, method is generally can be explained in three stages. One is first mesophilic stage, then thermophilic stage, and then another one mesophilic stage, and then some maturation, some screening, and with another some time, some we need to also maintain the moisture and temperature there. And firstly, then at the last we can have some very quality compost, which is having at least 12% organic carbon, 0.8% nitrogen, 0.4% P2O5, and 0.4% K2O. So, for doing this uh, composting process, if it is done mechanically, then the efficiency is more. So, one such reactor is developed by Indian Institute of Soil Science, and in association with the CIAE, Central Institute for Agriculture Engineering, Bhopal, as a RAPO composting unit. So there, this city composting is made much easier and in a much hastened manner for development of compost for maybe kitchen gardening, or maybe for the farm use in the farmers fields. Then a similar type of this compost preparation, and very important one, is vermicomposting. Here, no external this heat has been maybe provided. Here, this earthworms are given as means um, for basically composting of those different organic materials, and that also can be done in a mechanized way. So that vermicompost is also a very important part of integrated nutrient management, and has been proven over and over to increase the soil, means improve the soil structure, soil health, soil biological health, soil chemical and physical health. So that we need to follow. uh, Amresh, thoda sa. So again, so this kind of this compost when you're using, obviously this helps us uh, for means diversifying our nutrient sources, improving soil health, and also combating the pollution aspect of this materials. But as I mentioned, this is generally having a less amount of nutrient concentration. So for that, we can prepare enriched compost, and several several researchers, several ICR institute, also ICMR, I mean several CSR institutes are uh, doing research in that line, how to prepare some enriched compost. Now, if we talk about enrichment of compost, then there is several tons, like 160 million tons of rock phosphate deposits are available in India, but they are mostly low grade, means containing less than 20% P2O5. So, phosphate fertilizer cannot be made from those rock phosphate deposits. Similarly, uh, for in the Udaipur, if we visited Udaipur, we can see there is large mica mines are there. Those can be used for those are basically used for maybe for this cosmetic industry. Those micas are mined. So there is also a generation of a huge amount of waste mica products. So those waste mica products, or maybe those rock phosphates, they actually can be mixed uh, in this composting materials to prepare some enriched compost, which is having higher amount of phosphorus and this potassium content, and they can be used in the fields. So and they can again reported to cause significant buildup of organic carbon, available nitrogen, phosphorus, potassium, and also enhancement in exchangeable and non-exchangeable potassium. And reports are there that 50% of this nitrogen requirement can be substituted with this enriched compost material for wheat, potato, green gram, and soybean. So this enriched compost again makes a significant part of this integrated nutrient management. Then another nutrient source which is getting a lot of attention in the past 2 3 years, mostly, and mostly also in this uh, northwestern part of our country, Punjab, Haryana, Delhi, there is the crop residue. Now, since the advent of this combine harvester, means in the previous when this means manual harvesting were being done, then then all those harvested parts are generally baled, and they can be used for as a feed to the animal as an animal feed. They can be used. And then again, in this North Indian parts, the wheat crop residues, those are generally used as animal feed, but not the rice residues. And again, when we are using combine harvester, we can't just bale those residues. So those residues are evenly spread on the ground after rice harvest. So then again, it poses a challenge for timely sowing of the next crop, maybe wheat or maybe mustard. So uh, that gives a challenge. So so that needs to be addressed. And if those crop residues are actually retained on the field, they can actually provide a huge amount of soil organic carbon, obviously, and also a huge amount of nitrogen, then potassium, phosphorus, and some amount of micronutrients also. So uh, although this some cereal crop residues are valuable cattle feeds, but this could be used to supplement the fertilizers whenever is available in excess of the local needs. And uh, and then means that we can actually see in the Punjab, Haryana in the past few years. Uh, there actually has been cases of straw burning, and not only in Punjab, Haryana, in all the country. After the rice season, if we visit the farm fields, we can see the burning of residues. So that is again is a hazardous practice towards environmental pollution. So that we need to stop. And if we just stop those practices and use those crop residue as a fertilizer material, so we can substitute a great number of nutrient, means supply a great amount of nutrient through this crop residue only. For example, nitrogen released from rice residue ranged from 6 to 9 kilogram of nitrogen per hectare during the wheat season. Means if we retain those crop residues in the fields. Now, this actually gives way to conservation agriculture only, means sowing in zero-till conditions. Means we can actually incorporate those residues also, but keeping those as a mulch on the field is much more beneficial. We'll not be talking on those parts why it is beneficial. On some other aspects, we will talk about only the nutrient supply and potentials of this. Uh, there is a need to evolve appropriate management practices to make use of those stubbles, residues, and other on-farm and off-farm biomass, either by applying a part of fertilizer nitrogen recommended for this succeeding crop during land preparation, or by adding some cellulose decomposing microbial culture for hastening in situ decomposition. So there are certain decomposer microbial some formulations are there which can actually hasten the decomposition of this residue. So they can actually supply the nutrients, and also sowing is also very sowing can be done on those residue plots. And then for sowing in this crop residue retained plots, it's a important resource conservation technology, or RCT. So there we need this kind of sowing machinery like happy seeder or turbo seeder, which can actually sow the seeds of different crops, means here it's wheat, on those residues only. And here we can see wheat grown in a maize field where maize residues are still can be seen. So in that way, we are it's a win-win situation again. We are means decreasing the greenhouse gas emission, improving the soil organic carbon, and also using the crop residue as a nutrient source. And if we are doing this, then we can make some adjustment on the nutrient management schedule. So these needs to be means researched upon and fixed. Means if we are means for a certain crop, uh, uh, it can be done in the CA scenario, maybe some with some nano fertilizer spray, and then according to those practices, some nutrient fertilizers, means the general fertilizers, the traditional fertilizers, we may curtail. So that way we will be improving the nutrient use efficiency, nutrient use pattern of farmers, and it will be helpful for a sustainable future. Then if we talk about nutrient management, then in the INM, the another important component of integrated nutrient management is inclusion of legume in the cropping pattern. Now, different legumes have the capacity to leave behind different amounts of nitrogen for use by the succeeding crops. And further, the fodder legumes contribute more nitrogen than the grain legumes. Now we know this legume crops, they actually form the root nodules. The rhizobium bacteria forms root nodules in symbiosis with the leguminous crops, and they can actually fix a large amount of atmospheric nitrogen. And after the harvesting or death of that particular legume crops, a huge amount of that nitrogen will still be present in the soil for use of the next succeeding crop, right? And this carryover of nitrogen for succeeding cereal crop may be 60 to 120 kg in Barsim, 75 kgs in Indian clover, 35 to 60 kg for fodder cowpea, 55 kilograms for black gram, 50 kilogram for lathera. So a huge amount of nitrogen requirement for the succeeding crop can be made if we just include a legume in this cropping pattern. And several research has been done on this particular aspect, and grain yields of succeeding crop increased markedly with preceding legumes than a preceding cereal crop. So in general, pulse crops do leave a residual amount of as much as 30 to 50 kilogram of nitrogen per hectare for utilization by the succeeding crop. And if some inoculation, artificial inoculation has been is done with proper species of rhizobium, then these benefits of legume inclusion can be further enhanced. And these legumes, on the other hand, can grow very well even in the poor soils where nitrogen supply is not enough to support other crops. And then after harvest of those legumes, the roots left in the soil decay, releases fixed nitrogen for uptake by subsequent crops. And this not only saves money, but also helps to prevent other problems brought by the excessive use of nitrogen fertilizers. Because we know in our country, the fertilization practice is skewed toward nitrogen. And if we use these legumes, utilize those fixed nitrogen through rhizobium in root nodules, then again we prevent the excess nitrogen leaching and further pollution of the water bodies, and also acidification of oceanic water maybe. So that's why this legume inclusion in a cereal kind of cropping pattern is very important if you need to follow integrated nutrient management protocol. Then another important in this continuation of legume inclusion is green manuring. Green manuring, it is termed as green manuring because green crops are being grown in the fields and they are plowed down after the physiological maturity. So we can have green leaf or green stubbles, green stems. Those can be actually left on the field to supply a huge amount of nitrogen. And since it is cut down in a physiological maturity stage, so these are having a high amount of nitrogen content, which can supply nitrogen to soil and improve the soil nitrogen status. Now, if green manuring is done with legumes, it enriches the soil nitrogen due to the fixation of atmospheric nitrogen, and it also reduces the leaching and gaseous losses of nitrogen. And the decomposing green manure has a solubilizing effect on nitrogen, phosphorus, potassium, and other micronutrients, because these are also a source of micronutrients. And as it's a huge organic inputs in the soil, it enhances the biological properties of soil and also the physical and chemical properties. and some of the intermediate acidic metabolites are also produced actually. So those can actually solubilize the precipitated phosphorus, fixed potassium, and some precipitated micronutrients. So then it will not only act as a source of different nutrients, but also as a mediator for improving the availability of otherwise unavailable nutrient pools in the soils. And Sunhemp, there is Crotalaria gentiana, and Dhencha, this Sesbania, are the most important common green manuring crops. Now, for farmers, it often becomes difficult to accommodate a green manuring crop within an intensive cropping systems, and farmers do not wish to set apart 1 to 2 months exclusively for growing a green manuring crop with no direct economical benefit. In such case, raising a green gram crop in summer and incorporation of the above ground green biomass after peaking may also serve as a green manuring practice. And then this green gram residue incorporation, it has been found, could easily substitute around 50% NPK needs of rice, which amounts to around 60 kg of nitrogen, 30 kg of P2O5, and 15 kg of K2O per hectare in a rice wheat cropping system, without any adverse effect on total productivity. This also has been found to be helping in mobilizing the availability of nitrogen and micronutrients like zinc, iron, magnesium, copper. Now, these are the research findings of different institutes, different long-term fertilizer trials, different integrated farming system trials. So that I am sharing with you. So green manuring is a good option, but it is not having much of a economical benefit. So green gram crop is a very important green manuring crop. Maybe some PGNP also can be grown. Uh, and then again, where farmers are not willing to spare their scarce land resources and inputs for growing a green manure crop, their glycidia can be grown in the hedges or on the bunds of their fields, and their fresh loppings, fresh leaves can be used as a green manure, and those uh, have been found to have tremendous effect on soil physical, chemical, biological health, and also on the nutrient supplying capacity of those particular soils. Uh, in this line of research or line of thought only, there is another concept of induced defoliation. Now, this induced defoliation is generally practiced in case of PGNP, in a PGNP wheat rotation in this northern part of the country. So here what we do actually, we grow extra short duration varieties of PGNP, and after this PGNP attains this physiological maturity, means the maximum vegetative stage, there then a foliar spray of 10% urea solution has been are being applied at this maturity, and that actually induced the defoliation of those leaves, and it can supply up to like 2 point means up to like 2 ton per hectare leaf litter, which is significantly higher as if we go for natural senescence and measure that amount of leaf residue addition in this process. And this induced defoliation in case of a PGNP wheat system, it has the potential of recycling more than 40 kilograms of nitrogen per hectare. So it supplies a huge amount. It satisfied a major portion of the nitrogen demand of the succeeding wheat crop. So that can also be practiced. Now, when we are talking about residues, Means residues are a big problem, and uh, those can be used beneficially. Now, using those residues as a nutrient source, it calls for obviously conservation agriculture, maybe some machinery like happy seeder, turbo seeder, which can actually sow the wheat crops in those anchored residues. Now, again, it facilitates, but it will even be better if we can use some external microbial decomposers. So this microbial decomposers are basically a consortium having some lignocellulitic, amylolytic, proteolytic, lipolytic, pectinolytic, thermotolerant, and phosphorus solubilizing bacteria. Sorry, some fungal composition. So several decomposers are being developed across the country by different institutes and also different private players. Uh, Similar one very successful this microbial biodecomposers is PUSA decomposers developed by the Division of Microbiology in the Indian Agriculture Research Institute. Uh, this is also having a inoculation, inoculum of this different fungi for large scale bioconversion of horticulture or agriculture residues. And this is generally available in some capsules which is having the inoculums. So if you talk about the process, how to do it, then we have to take the capsules, maybe add some jaggery, some gram flour, and some water, then lukewarm solution of that jaggery, and then addition of that capsules in those in that slurry kind of thing, and then we wait for the mat formation, means proliferation of those fungal consortium. Then from those 4 capsules, actually that's a kit, we can actually develop 10 liters of solution that can be spread on means on field after the harvesting of rice residue through this combined harvester. So we can spray those PUSA decomposer solutions, which actually hastens the decomposition process, and obviously it will improve the soil biological health, soil chemical health, and soil physical health also. So we will go towards a sustainable kind of agriculture future if we use this kind of interventions in our agricultural nutrient management. Then another very important nutrient source that is gaining potential nowadays for past few years, there's the seaweed based plant growth promoters. Now seaweeds are means since we are these are the basically coral like structures, uh, and we have a long coastline. India have a long coastline with a 12 nautical mile territorial sea, and exclusive means there is a huge potential of this seaweed production. And it has been found this seaweeds, these extracts, they contain essential macronutrients, micronutrients. Apart from those, it also has several plant growth regulators like indolacetic acid, gibberellins, cytokinins, glycines, betaines. So this is a very important nutrient source, along with a source of different plant growth regulators. So it's a very cheap and very what we can say very good source, good organic source of fertilizers. And due to this very this benefits, research are ongoing on different ICR institutes, and also most importantly the CSIR, CSM, CRI institute. They are trying to commercially cultivate this important seaweeds and make the seaweed extracts, and then from that seaweed extract fertilizers, maybe as fortified granules, and also some products are there with which is seaweed based product, which is also available in spray. And from our research experience, we can say that when we use that seaweed based extract fertilizer material as a spray material, so we have a very beneficial or very good effect on the plant growth and also yield parameters. So this CSRI, CSM, CRI, they actually are working on uh, Kappa ficus alvarezi and Gracilaria edulis in India. They are researching in this and producing some very good results. And in the market nowadays also some seaweed based fertilizers can be found. So these also needs to be incorporated in the nutrient management schedule. That's why decreasing the load on the traditional fertilizers like urea, DAP, etc. Then let us come to what we can say. Uh, Talked about component of INM, and also much important we can say there is the biofertilizers. Obviously, that Fusa decomposer, those also comes in the purview of these biofertilizers. Uh, but this is a these biofertilizers are basically the products of some beneficial microbes which can increase the agricultural production by way of nutrient supply, especially of nitrogen, phosphorus. Nowadays, obviously, zinc, potassium, all those biofertilizers are also available. Now, these are not a source of nutrient as it is. What they can do, they can actually utilize the nutrients that are present in the soil or maybe in the atmosphere in an unavailable non-available form, and they can convert those forms uh, to a plant available form. Thus plant can take up those nutrients. Now biofertilizers are of different type. Maybe rhizobium, which is obviously can be used in leguminous crops. Then Azotobacter, which is a nitrogen fixer for the cereal crops like wheat, maize, maybe cotton, mustard, and some vegetables also. Then there is Azospirillum, which is again an nitrogen fixing microbe, which also can be used in some cereal non-leguminous crops basically. Then there is blue green algae, which is very much beneficial for managing the nutrient requirements of rice. Then there is arbuscular mycorrhizae. This is used for nursery raised crops and orchard trees, and also for general crops. Also, we can use this. Then there is phosphorus solubilizing microbes, and there is potassium solubilizing microbes, and there is zinc solubilizing microbes. So those, if are used with in combination of this other different nutrient sources, we can actually we can actually improve the nutrient use efficiency and go for a sustainable agricultural production system, right? And rhizobiums, as we means from the researches we can find that it can fix around 50 to 100 kilograms of nitrogen per hectare, which is a very huge amount actually. And now since rhizobium is very specific to each legume, that needs to be followed, means recommended inoculant should be used for recommended means each leguminous crops. Then again, for the non-legume crops, Astrobacter can be used. It has the potential of saving nitrogen, chemical fertilizer nitrogen by 15 to 20 kg nitrogen per hectare. It can supply that amount. Then phosphate solubilizing microbes also are giving us very good results in the experimental fields. And in general, it can save around 40% of the crop's phosphorus needs if used judicially. Now, if we now see a bit how this can be applied in practical, this is basically Rhizobium, Astrobacter, Aspergillum, and other also PSB cultures or other the KSB cultures. Those are basically used as seed applications, seed inoculation. Uh, some 150 200 gram packets are available for seed treatment for 1 acre of land. So again, means we have to prepare a jaggery solution or sugar solution. Use that material, dip our seeds, and then we cool those seeds. Actually, means seed coats. Means these will actually coat the seeds, and then we need to sow those. Means we need to dry those inoculated seeds and sow immediately. So that's how we actually apply those dry microbial biofertilizers. Then there is another very important biofertilizer in this product range, that is arbuscular mycorrhizae. Now these are symbiotic association between plants and a specific group of fungi. And this hyphae of this mycorrhizae from a bridge between plant and soil and serve to cater the requirements of plant nutrients, especially phosphorus and trace elements like zinc, iron, copper, cobalt, magnesium, molybdenum, etc. Now this actually mycorrhizae, this acts as a extension of the plant roots. This is very helpful in the soil which is inherently nutrient poor, means poor soil health. So there some nutrients, maybe phosphorus, maybe micronutrients, may be present, but present in some corners or some pockets of the soil where plant roots cannot reach. So in that case, this mycorrhizal hyphae generally behaves as an extension of the plant root and can absorb, can solubilize, can mobilize those phosphorus, iron, zinc, means elements from those parts, and can make those elements available for plant uptake. And then again, it also promotes the soil aggregation by their hyphae structure, uh, prevent soil erosion, reduce the soil degradation. So they can, and if we manage the soil erosion, then again we are actually managing the nutrient loss, which will also occur otherwise with the soil erosion. So using arbuscular mycorrhizae in the integrated nutrient management can be, I mean, it is actually proven to be a very good uh, nutrient management option in case of different crops. So here also 5 kg of this mycorrhizal inoculant is sufficient for treating 1 acre of land. So it needs to be mixed with field soil, FIM, vermicompost, maybe in the ratio of 1:20, and applied near the feeder rows. And the inoculant has been found very useful in crops like coffee, tea, papaya, coca, oil palm, etc. And also in case of different cereal crops, this can be used and generally is being used in several areas. Then another very important biofertilizer is blue-green algae, which is found much beneficial for paddy cultivation, and it provides not only nitrogen but also organic carbon and other growth promoting substances. And it is also mixed with soil in standing water of the paddy field after the transplanting of the seedling. So it can give a benefit of 20 to 30 kilograms of nitrogen per hectare. Then another biofertilizer, another important biofertilizer is azolla. It is also important in biological nitrogen fixation in the paddy fields. It's a free-floating water fund which is in symbiotic association with anabina. And this azolla can contribute again around 40 to 60 kilogram of nitrogen per hectare per crop, depending upon the rate of azolla application. And azolla can be produced by an individual farmer also for use in paddy field. After 15 days of growth, means they can be cultivated in that field only. 100 to 150 kg azolla can be harvested from one plot. So this is a very good way of supplementing the rice nitrogen demand by using this azolla and amina and also the other blue-green algae. So we can use this one, which then again will increase the nutrient use efficiency, decrease the nitrogen leaching losses, nitrogen denitrification losses, volatilization losses, which is a big problem in case of nitrogen application in submerged rice. So this has a huge potential in using in case of the nutrient management, integrated nutrient management in case of the paddy cultivation in Indian scenario. Then nowadays some liquid inoculants are also there, as I was saying. Zinc solubilizing nutrient, zinc solubilizing microbes are there, zinc solubilizing bacteria basically. Then potassium solubilizing microbes are there. So uh, means this inoculation of zinc solubilizer can augment up to 2 to 5 kg of zinc per hectare, whereas this potassium solubilizer they helps to augment like they can supply 10 to 15 kilogram of potassium per hectare from soil potassium reserve on, and also from the otherwise unavailable pools of soil zinc. So this way they can again increase the use efficiency of the zinc and potassium, so they can be used. Now, from our research, we are actually basically doing research on development of different integrated nutrient management protocols. Uh, means if means one such protocols we are means we can say that this if we use the nano urea, we can apply the 2 sprays of nano urea and we can reduce the 25% of nitrogen application through urea basal dose. Then again, if we use under this conservation agriculture, if we retain like 4 tons of crop residue along with the green seeker based in application, means which is in synchrony with the crop nitrogen demand, we can actually curtail up to 24 to 48% of the fertilizer nitrogen demand, which is very huge. So then we can use enhance the nitrogen use efficiencies and means we done this in a maize width system, so we can save a certain amount of in management under this conservation agriculture, where we are using 4 tons per hectare of crop residue of the previous crop. And in those conservation agriculture only, we also used p solubilizers, arbuscular mycorrhizae, and also K solubilizers, along with that retention of 4 ton per hectare residue. So those also means we found results that this can actually substitute means like 50% of the recommended potassium or phosphorus fertilizer doses can be curtailed in case of basal application if we use this PSB, KSB, or arbuscular mycorrhiza. So we integrate them in the nutrient management schedules. So this kind of nutrient management protocols we need to develop actually for our for effectively using the integrated plant nutrition system. So I think we might stop here.